Many people tend to take for granted that their digital data is always safe. However, with the increasing number of cybersecurity threats, such as ransomware, human errors, or hardware failures, it's essential to be prepared for any eventuality. This is where backup storage comes into play. Backup storage is the process of creating backup copies of important data and storing them in a location separate from the main system. This approach provides a vital safety net to ensure the availability and the integrity of both business and personal data. But backup storage is not just a matter of copying files from one place to another. It's crucial to plan carefully how these backups will be managed and retained. Let's start with the various types of backups, each of which plays a crucial role in safeguarding our digital data. Understanding the differences between these backup types is essential for creating an effective backup strategy and ensuring the security of our data. Let's start with the mirror backup. This type of backup is the simplest to grasp. Essentially, it involves an identical copy of all data from a source to a destination. This means that every time a mirror backup is performed, all data is overwritten with the latest version from the source. If you're looking for a complete and instantaneous backup, mirror backup is the way to go. However, it requires significant storage space. Full backup is similar to mirror backup but takes a different approach. Here, all the data from the source is copied to the destination, but existing data is not overwritten. Each full backup creates a complete snapshot of the data at the time of the backup. This requires more storage space than mirror backup but allows you to retain several complete versions of data over time. Moving on to incremental backup. In this type, only the data that has been modified or created since the latest backup is copied. This means that subsequent backups are faster and more storage efficient compared to full backups. However, it's important to note that to restore all data, you need both the latest incremental backup and the most recent full backup. Finally, the differential backup is a compromise between full and incremental backups. In this case, all data that has been modified or created since the last full backup is copied. This means that differential backup requires less storage space compared to full backup but more than incremental backup. You only need the latest full backup and the last differential backup to restore all data. Now let's move to discuss a fundamental aspect of data validation through checksums and CRC, cyclic redundancy check. In our digital age, where data is critical asset, ensuring the accuracy and integrity of the data is of paramount importance. Whether you're transferring file over a network or storing important documents or downloading software, the risk of data corruption or errors always exists, right? This is where data validation techniques such as checksums and CRC comes into play. A checksum is mathematical value that is computed from the data in a file or a block of data. It's like a unique fingerprint for your data. When your data is transferred or stored, a checksum is generated for that data. This checksum is then transmitted or stored alongside the data itself. When the data is later retrieved or transferred again, a new checksum is calculated from the received data. If this new checksum matches the originally transmitted checksum, it indicates that data has not been altered or corrupted during the process. However, if the checksums do not match, it signals a potential issue with the data. CRC or cyclic redundancy check is another powerful method for the data validation. It is a more complex algorithm than simple checksums and is commonly used in network communication and data storage systems. CRC adds a level of redundancy by performing mathematical operation on the data, generating a value that is open to the data. When the data is received or retrieved, the CRC value is recalculated from the received data, and if it matches the appended value, it confirms the data's integrity. In conclusion, the use of checksums and CRC for data validation is essential in today's data-driven world. This technique helps ensure that the data we transmit or store remains intact and accurate. While checksums are lightweight and suitable for many applications, CRC offers a more robust solution for scenarios where data integrity is absolutely critical. Now, let's explore a critical concept in the world of data management and disaster recovery. The recovery point objective, commonly known as RPO. RPO is a fundamental metric that organizations use to define their tolerance for data loss in the event of disaster or in a planned outage. In a sense, RPO represents the maximum acceptable amount of data that an organization is willing to lose or be without in the event of a disruptive incident. To understand RPO better, let's consider an example. Imagine a company performs daily backups at midnight. If the RPO for this company is set to 1 hour, it means that they are willing to tolerate losing up to 1 hour's worth of data. In the event of a disaster or system failure, the organization aims to recover to a point no later than 1 hour before the incident occurred. RPO is a critical aspect of disaster recovery planning. It directly influences how frequently data backups are created and how quickly systems can be restored after a disruption. Organizations must align their RPO with their business needs and risk tolerance. For example, financial institutions or healthcare providers may require very short RPOs due to regulatory demands and the critical nature of their data. In conclusion, understanding and defining the recovery point objective is a crucial step in disaster recovery planning. By setting an appropriate RPO, organizations can ensure that they can recover their data and system to a state that aligns with their business objectives in the event of an unexpected incident. Now, let's move to an exciting exploration of RAID technology. Before you think we're talking about insects or some secret agent organization, let me clarify. RAID is not a pest control squad or nor its spy agency. Instead, it's a fascinating approach to data storage and protection that plays the role of digital superhero squad for your precious information. RAID, which stands for Redundant Array of Independent Disks, may not wear caps, but it's here to save the day when it comes to storing and safeguarding your data. Think of it as your data trusted guardian, ready to defend against data disaster and ensure your information safety. So, let's embark on this data protection journey where RAID technology takes the center stage as our digital superhero. RAID 0 is a configuration that focuses on performance and does not provide redundancy. In RAID 0, data is split into blocks and distributed across multiple drives in a way that enhances read and write speeds. This stripping process results in increased data throughput as multiple drives can work simultaneously. However, the drawback of RAID 0 is that there is no data redundancy. If one drive fails, all data is lost, making it a risky choice for critical data storage. RAID 1 is a configuration that prioritizes data redundancy and fault tolerance. In RAID 1, data is mirrored across 2 or more drives. This means that each drive contains an identical copy of the data. If one drive fails, the data remains accessible from the mirrored drives. RAID 1 offers excellent data protection but does not provide any performance benefit like RAID 0. RAID 5 combines elements of both performance and redundancy. In RAID 5, data is stripped across multiple drives like in RAID 0, but with an additional feature, parity. Parity information is distributed across all drives, allowing for fault tolerance. If one drive fails, the data can be reconstructed using the parity information from the remaining drives. RAID 5 offers a balance between performance and data protection. It is often used in enterprise environments for file servers and data storage arrays, where both speed and fault tolerance are required.